Hey guys, today in class we did some work with combining like terms, well actually canceling out and combining terms when they're on different sides of equations. So we'd already done that with constants, and then we looked at it today when we had variables on both sides of the equation. And something that's important about looking at the equation itself before we solve it is determining number of solutions. So in your notebook for your summary tonight, we're going to make a title, and I'm using white paper just so that I have space and it's clear so you can see what I'm doing. You should just do this in your notebook as a normal title. So we are going to put our title as number of solutions. And what that means is how many answers we're going to get for our variable. So our choices, once you have this, you could split your notebook into 3 sections as best you can. You know, I can't draw a straight line. And in our first section, we are going to look at basically what we've already done. So when we have the variable that has one solution, the middle column will be when there is no solution. So that means there's no answer for x that works. And then lastly, when we have infinite solutions. And the key word there is infinite or infinity. So infinite, another way we label that, if it's infinity, it's everything that we can imagine, so all solutions. And basically what that's saying is no matter what we plug into our equation for the variable, or x I'll use today, that we are going to have it equal out no matter what. Okay, so I'll give you a second to copy that down. And then like I said, I'm going to do 1 page per solution here, and you could just follow along and put them in your appropriate columns. So the first column is the one solution. And I know something has one solution if the variable terms on both sides are different. That is the best way to describe it. So let me show you an example of what that means. Variable terms on both sides are different. So today we saw our equations, equal sign in the middle, right? We had a problem and then a problem. So just for example, let's do 2x plus 1 equals 4x plus 2. Something really basic. So before I solve this and decide what x is, I can look at this problem and determine whether I'm going to have one solution, no solutions, or infinite solutions. Obviously this one has one solution if I'm putting it under this example, but let's discuss why. So variable terms on both sides are different. Here's my variable term over here. Here's my variable term over here. I can see that the coefficient, or the number in front of my x, is different on both sides. So I already know that I'm going to end up with one solution, and it's up to me to determine what that solution is. So let's try it out. Put our line down the middle. I have x's on both sides. I need to get them to one side. To me, it makes more sense to subtract 2 from both sides and have 4 minus 2 than to do minus 4 on both sides, because then I would have 2 minus 4. That gives me a negative, and I wouldn't necessarily get the wrong answer, but it's not going to be easy to work with. So I will subtract my 2x term to get rid of it on this side. Got to do the same on the other. And let's bring down what's left. I have a plus 1, I have equals, I have 2x, and then I have plus 2. So I can see I have a two-step equation now, two things happening to the variable that I need to undo. So I will subtract. That's gone, they cancel. I'm left with 2x. And then 1 minus 2, I can do keep, change, change. 1 plus a negative 2 is a negative 1. Last step, let's divide by 2. Divide by 2. So x equals negative 1/2. And that is one solution. X equals one thing. And that's all that x can be. Okay? No solutions. So these last two, no solution and all solution, I've noticed that students sometimes get confused between the two of them. So let's decide how they look first. If something has no solution, an equation that we're talking about has no solution, it could possibly look like this. It could be variable terms are the same on both sides. And then going along with that, the constant terms, and constants are those numbers, regular old numbers by themselves, are different. So variable terms same, constant terms different, and that's going to tell me that there's no solution for my problem. Let's try this one. 3x plus 4 equals 3x plus 5. When I look at this, I can clearly see again, equation split down the middle. It's not problem equals answer or problem equals answer, it's problem equals problem. So I know that I have to probably solve for x, but before I'm going to do that, let's see how this proves that there is absolutely no solution. Variable terms are the same on both sides. Here's my variable term, 3x. Here's my variable term, 3x. Okay, they're the same on both sides, so that's a check mark for that one. Constant terms are different. Remember, my constants are just these regular old numbers. Well, here's a 4, positive 4, and here's a positive 5, and those clearly are different. So before I solve this, or if I'm able to solve it, I already know that there's not going to be a solution for x. But let's demonstrate why that works out. So we don't want x's on both sides. We practiced that today. So it doesn't really matter which side I subtract here, because they're both 3x. So I'm going to get rid of this one. And I did this one, so that cancels. 5 is left here, equals, well, these cancel too, because if I have 3x and I get rid of 3x, I have no x's left. So I don't even have to put anything, they're gone, and that leaves me with 4. So if we look at the end of this, there's nothing more for me to do. 4 equals 5. Well, I don't know about you, but in my world 4 does not equal 5. So if we ended up with something like this, no, they don't equal. Those are our constant terms that are different from each other. 4 does not equal 5, so this is no solution. There is no value of x that I can plug into this equation that will work. All right, lastly, let's talk about all solutions. So all solutions is going to look extremely similar to no solutions, except one word is going to be different. First, variable terms. Did I spell that right? Yes. Terms are the same on both sides. Okay, so that is pretty much the same as this so far, right? They look the same. But next, constant terms are also the same. This is the problem that I call identical twins. So after I've distributed, combined, solved, after I've done my DCS, what I end up with is a problem on one side that is identical to the problem on the other side. And remember, again, this is after distributive property, combining. You'd end up at this point, and you have to do your final combining step, but you'd go ahead and solve it. So all solutions means no matter what I plug in for x, it's going to work out. And let's demonstrate why that happens. I can go through the process of canceling. I'm actually going to do more than one with this. So I can go through that process of canceling again. Get rid of my 3x's. My variable terms are the same. And so they're gone. That leaves me with 4 equals 4. Well, in my world, 4 does equal 4. So that works out. Versus before, we got 4 equals 5, and that doesn't work. So that, to me, when they equal out at the end, that says that I have all solutions. Let me rewrite that problem quickly, and you can add this below. And let's talk about what that means as far as actual answers. So let's just throw in the mix here. Let's say that I put x equals, equals 1. Okay, well 3 times x, which is 1, plus 4 equals 3 times x, which is 1, plus 4. 3 plus 4 is 7, equals 3 plus 4 is 7. Okay, it works. I could try x equals negative 5. 3 times negative 5 plus 4 equals 3 times negative 5 plus 4. So I have negative 15 plus 4 is a negative 11, and that equals negative 15 plus 4 is a negative 11, which also checks out. So I think you're kind of getting the hint here. No matter what value I plug in for x, it's going to equal out on both sides. So that would be all solutions. Tonight, just come in ready tomorrow with these 2 problems done. And I want to know number of solutions. So that would be number of solutions after you DCS the problem. Okay, number 1, let's say that I have 5x plus 2x plus 8 equals 7x plus 3. How many solutions to that problem? 2, let's go ahead and try 2x plus 4 plus a negative 2 equals 2x, what do I have here? Plus 6. Okay? Come in tomorrow ready to talk about those. Make sure you have your notes good to go. We have a lot to practice with this. All right, see you guys tomorrow. Have a good night.